called chemical calculations or Stoichiometry. I'm not sure if the spelling's right, but yes, it's how you pronounce. Stoichiometry means chemical calculation. So I said real chem starts from this chapter, right? Last class, 이런 거. CuSO4, so what else we got? Say NaOH. I'll just try 3. MgBr2. Right, so here, first of all, let's quickly review last class. 누구냐? 태균이. 이거 첫 번째 거 이름 뭐야? What's the name?
Copper.
Go on.
That's metal. No, that's transition metal plus.
So if I give you a hint, that's this. That's from polyatomics.
Yeah.
So what's the name?
Is it sulfide or
Sulfate.
sulfate?
Fate, right?
Fate.
But remember, close, copper, sulfate. However, when we use the transition metal, what was the rule? We use Roman numeral to indicate the charge. If this one has 2 minus charge, that automatically implies this guy has positive 2 charge, right? So it should be copper 2 sulfate. Now, 누구냐? 태영이. NaOH. What's the name? Same rule applies, but a little bit different. Can you?
Sodium.
Go on. Sodium. Well, that OH is OH minus. Again, hint. You guys should start memorizing the polyatomics, okay? So that's sodium hydroxide. 자, 마지막 거. 태균이 one more chance. 이름 뭐야?
Magnesium. That's beryllium. Diberyllium.
So here, that's go on.
That's
Yeah,
one metal plus the.
that's metal.
That's metal.
Right.
Magnesium is metal.
Magnesium is metal. That's
Metal
from group
plus-
2.
Yeah, metal plus Br, non-metal.
Right. So you learned 4 rules. Which one applies?
The fourth.
First one. Last one was non-metal, non-metal.
The number of elements
Do not matter. So here, first rule, metal, non-metal. Then it's magnesium bromide.
bromine.
Yeah, that's the name, right? Okay. Magnesium bromide. So So this was from naming compound was chapter 3. However, again, in chem, mass versus molar mass, we use this term the most though, molar mass, okay? Gram formula mass. Also, say molecular mass. These all mean the same thing in chem. Slightly different, but we treat it the same. And atomic mass unit, whatever. But we use the term molar mass most commonly. Where do we find the molar mass? We look at the compound and we use periodic table, right? So here, copper sulfate. Here we have 1 copper. Copper is 64. The unit for molar mass is gram per mole. Don't worry about the unit for now, okay? Don't worry about the unit for now. It's 64. S is 32. Oxygen is 16, but we have 4 of them. This adds up to 160 grams per mole. Can you check? Copper, how much is it? 4, right. S, right. Oxygen, that's how you do it. 자, 그러면 태균이 NaOH, what's the molar mass?
23 plus 16 plus 1.
Right, so that's
40.
40, right. So that's 40 grams per, that's molar mass. 태영이 마지막 거. MgBr2, what's the molar mass?
24 plus
Uh-huh.
160, so
Yeah.
184.
That's exactly how you calculate the molar mass, okay? So now, in chem, can I erase everything? No?
Oh, good.
Yeah, go on.
Yeah.
Now, chem에서 이런, we have a concept called mole, alright? Mole. 일단 지운다. mole은 뭐냐면, the general formula is mole or just mole is mass over molar mass. 이거 언제까지 알아야 돼? AP Chem 끝날 때까지. Mole is mass over molar mass, alright? And I said mass is certainly different from molar mass. Molar mass we use periodic table to calculate, right? 근데 예를 들어서 얘가 이렇게 문제가 준 거야. We have, say, 80 grams of CuSO4, 20 grams of NaOH, and say 92 grams of MgBr2. Then that's mass, alright? And if the question says, please calculate the number of moles, you simply apply this formula. Accordingly, 이거 한번 해보면 80 over molar mass, 160. 20 over 40. That's 92 over 184. We get 0.5 mole, right? So that's the basic concept of mole. Just know mole is mass over molar mass. Okay? Alright. 알겠지? Mass will be given in the problem. Can I move on? Okay, now. Here, please copy this chart. Does the direction of arrow matters? Yes. Yes. Okay, so please draw carefully. This MM represents molar mass, okay? Molar mass. 이거 은근히 재밌어. 이게 뭐냐면 here. So say I'll just give you the basic information, okay? First, the general concepts. You treat each circle as a bus station. All right, bus station. In order to go from one station to the other, you have to pay a fee. You think of these mathematical operation as the fee, okay? 무슨 말인지 알겠니? So 돈 내면은 if you pay, you move on to the next station, and next station, and next station. The question will tell you to move from which station to move from which station to which station. Let me give you an example here. I'll tell you how to utilize this chart. Alright. Okay. Let's say 10 grams, X grams. So I made a, question real simple, but in reality, the question will explain. We have 10 grams of H2, which will react with O2. How much H2O will be produced? So simply, we're given 10 grams of H2. How much H2O will be produced in grams? That's the question, right? Now you think, 태균, which station is which station으로 가는 거야?
Mass to
Mass. Whatever you have is always the A, okay? We're moving from mass A to, what are we trying to calculate? Other substance mass, right?
yeah,
Mass A to
mass B.
mass B. What do? Follow the arrows. I really think this is the easiest way to teach, okay? 이거 다 알려주는데. Okay? 하면서 let us apply. So we start, like Taegun said, we start from 10, mass A, divide by molar mass. What's the molar mass of H2?
2.
When you calculate the molar mass, you do not consider this for these problems, okay? That number in front, we call it coefficient, we only use it in balance ratio. Do not use them when you calculate the molar mass, okay? So 10 over 2, good. We paid, so now we are here, okay? We're here. 여기서 일로 갈 때, it says use balance ratio. 얘는 balance ratio 몇 대 몇? 2대2. So put 2 to 2. However, we started from substance A, right? Substance A's balance ratio always has to go to bottom. What you start with goes to the bottom, okay? Keep that in mind. Let me say it one more time. What you start with, the balance ratio, for the balance ratio goes to bottom. Now we paid the balance ratio, we're here, we want to multiply molar mass of substance B, which is H2O. Again, we don't consider this number. H2O's molar mass is 18, okay? So based on 10 grams of H2, we will have 18 times 5, 90 grams of water produced. This is it. 이것만 있으면 다 할 수 있어, okay? Let me show you one more. I'll let you try a lot of problems today because this is very important, okay? 딱 봐도 it's a core of chemistry, isn't it? Okay? Let me give out one more problem. Let me create one, okay? So N2, H2, NH3, that's 3 and 2. So say we have 2 mole and we want X grams. Oh, let us try one more time. Again, I made it simple, but the question will say N2 reacts with H2 and produces NH3. And then we're given 2 moles of N2. How much NH3 do you expect to be produced? Okay, that's the full question. Okay? So that 태영이, you guide me. Where 어디서 어디로 가는 거야 이거? Which station to which station?
Mole A,
Go on.
mass B.
Mole A to mass B, right? So start with mole A, that's 2. We're here. We have to pay the balance ratio, that's 1 to 2. What you start with goes to the bottom, 1 to 2. From here, you multiply molar mass of substance B. That has to be 17 if you check, okay? N is 14, we have 3 hydrogens. That's 17. Right, so how much? 17 times 4? 68 grams. That is the answer. Right? Yeah, I mean, some teachers, like, again, the really 깐깐한 사람들. If you just write this, they may be offended, okay? Because, 원래 이거는 진짜 shortcut이거든, shortcut. Okay, so, decide if your teachers are lenient or whatever, okay? But it's not a wrong method. You will always get the correct answer. Okay? But in reality, 원래는 이게 조금 더 work가 복잡해. 무슨 말인지 알겠지? 원래 full work should look like this. So 2 mole of N2. The balance ratio 1 mole of N2, 2 mole of NH3, and molar mass of NH3 17 gram per mole. And this is the full work, but I don't do that. Right? Okay? Alright, so this is it. That's called stoichiometry. Let me just do one last one. So again, I'll use the same example. N2, 3H2, and 2NH3. However, okay. So this is kind of like reverse problem. So the question will say, based on this reaction, 34 grams of NH3 is produced. How much H2 did you really use? That's the question. But again, what you have as the starting information will always be the A part, A. That's mass A to mass B. Same thing, let me try one more time. So mass A, that's 34, divided by molar mass, which is 17. Mole rate, we're now here, the balance ratio between NH3 and H2 is 2 to 3. What you start with goes to the bottom, so that's 2 to 3. Now we are here, you have to multiply it by molar mass of substance B, which is 2. So that's cancel 1 to 6 grams we used. That's it. Are we good? Can I erase the board? Okay. Can you turn to the what? However, again, when you do the stoichiometry, right? What's the first thing you might want to do? You want to check whether the equation is balanced or not. Some teachers just don't balance it on purpose. Does that make sense? 일단 balance 돼 있는지 확인하고, then you want to use the chart to calculate whatever they ask to. That's it. Okay, so here. So you do need a calculator today, guys, right? Not just today, but again, every day. Now, given that we finished the basics of stoichiometry, right? Now we're going to move on to something called limiting reactant. Okay. Limiting reactant. So how about this? So when you mix yellow with blue, what color do you get?
Green.
Green, right? 근데 내가 what if I have this amount of blue, I have this amount of yellow. Oh, this amount of blue, this amount of yellow, okay? When you mix the two, how much green will you get? 요만큼. Right? Even if you have a lot of say yellow, you can't make more because you only have limited amount of blue, right? So it's the same, logic. That substance among the reactants or between the reactants, substance that controls the amount of product is called limiting reactant, okay? So amount of product depends on really limiting reactant. 이런 거 되게 많은 거 뭐라고 해? Excess reactant, right? So at the end of the reaction, all the limiting reactants will be gone. It will be 0 grams. Excess reactant, you'll have leftovers. Clear? So let me give you something, guys. Here. Can I take off my mask for 5 minutes? It's really annoying. Okay, I'm sorry. I mean, if you feel uncomfortable, please tell me to wear it. All right, let me just 5 minutes. I'm getting old. Getting old. Here. So before we only had 2 numbers, A and B. Now we will have 3 numbers. Okay. When you go into AP Chem, maybe 4 numbers. But say you have 32 grams here, 32 grams here, and we need X grams of CO2. So it's completely different from earlier scenario, 맞지? 그러니까 상식적으로 니네 job이 뭐야, job? You need to find the true A. Is this the A or is this the A? That's what you have to think about. Once you decide A, you follow the previous procedures, same. So only extra job here again is finding the true A. That's it. 자, 볼게. So there are, here guys, there are about 5 ways to find limiting reactant. I will only teach 2. But again, you'll get the same answer. 학교 가면 다를 수 있어, okay? But 우리 선생님 그때 단일 이렇게 안 갔으니. Don't do that, alright? You will get the same conclusion, you will reach the same number. But here's the 정석. 정석이 뭔지 알지? Like formal manual. Here, 1. You will need these numbers in moles, okay? But if it's in moles, leave it as it is. So mole, again, is mass over molar mass. So 32 over, what's the molar mass of CH4? 16.
6 plus.
Right, so that's 16. Molar mass is 16. How about O2? That's 32 over 32. We have 1 mole, correct? So the next step is set up something called mole problem. And the other one is called mole equation. But mole equation is really the balance ratio. So let me show you. Balance ratio. Let me show you. So for this problem, it's simple. I'll write the mole equation first. In this case, mole equation, it's going to be CH4 over O2. What's the balance ratio between them? 1 to 2, right?
Yeah.
So 1 to 2, that's it. But mole problem is something we just calculated, given in the problem, these numbers. So mole problem, I'll give you time to write. Focus for now, please. Okay, please, I'll give you time. Mole problem here is, if you put the CH4 in the numerator, you should do the same. You have to make it coherent, okay? That's CH4 over O2. How much was it? That's 2 to 1. Yes? Who's bigger?
CH4.
Oh, I'm saying, is mole problem bigger or mole equation bigger?
Mole problem.
So that's the rule. That's the formal manual. Here, let me write it down. If mole problem, NP, is greater than mole equation, then 1 in denominator is your limiting reactant. That's your true A, it means. If mole problem is less than mole equation, 1 in numerator is your numerator. I'm having difficulty with spelling things, god damn it. And then if it's same, it doesn't matter which one you use. Doesn't matter. So in this case, so which one is the mole problems? Then who's our limiting reactant?
O2.
1 in denominator. Correct. So what does that mean? This is your A, this is your B. We follow the same procedure. If I do it really quick, 32 over 32, that's 2 to 1. What to start with goes to my molar mass of CO2 is 44. I get 22 grams of CO2 produced, and that is the answer. 됐나? 요것만 잘 하면 돼. 요것만. Can I move on? Yes, yes, please, guys. Write down. Yes. Okay, now, here. So that's the formal manual. If this is enough for you guys, I'm not going to even bother with the other method. Do you want to see it though? Or not? I don't mind. This is enough. Do you want to see? Okay, here. So I guess Kim doesn't trust me, right? Thinking that 모르는 것 같은데. No, here. Here's the way. So I changed the numbers to, this is actually the way I use it. It's a lot faster, okay? If you get used to the chem, you can use it. So that's 1 mole. That's 1 mole. No, that was 2 mole, right? Using the numbers, mass or molar mass. So this is kind of like manual. When you say create toys and stuff, there's a manual, right? The manual says, in order to produce CO2 and H2O, you need to put 1 mole of CH4 and 2 mole of O2, correct? So here's what you do. Manual says 1 to 2. When you have 2 moles of CH4, how much O2 do you need? Think again. Manual says you need to mix 1 to 2 ratio, right? When we calculate the number of moles for CH4, it was 2 moles. How much O2 do you need? 4? 4. But we only have 1. That means this is the limiting reactant. Let me do it one more time. 1 to 2. We have 2 moles of CH4 as given. That means we need at least 4 moles of O2. But we only have 1 mole, right? 1 mole, right? That means your limiting reactant is O2. But if it's confusing, again, use this. Use this. Okay? So as a practice, use this. And then later on, when you get used to it, I will revisit this another method. 됐나? Okay, so here. What was the other job? So based on the limiting reactant, we calculated the amount of product that the question tells you to calculate, but there's one extra job. Then, so if for this problem, this was limiting reactant, we say this is excess reactant, right? How much is left in grams and moles? That's your next step. Okay? 하는 방법 is this. 태균, you guide me. 누가 리미팅이었다고 이 문제에서?
O2.
그러면 이거는 이제 가려. Alright? 없다고 생각해. You just do mass A to mass B. You do it. So let me do it. So that's 32 over 32. The ratio is 2 to 1. Molar mass of CH4 is 16. How much do I get?
That's
8. That means 8 grams of CH4 required. How much were we given with? How much is left? That's the answer. Simplest way to teach, okay? That's 24 grams left. If the question says, please calculate the amount left over in moles, you simply do 24 grams left over molar mass of CH4 is 16. That means 1.5 mole is left, or 0.5 mole is used. Clear? Let me show you another example. I'll do this problem one more time. Can I? Okay, here. So we need to find limiting reactant. 2. Based on the limiting reactant, X gram, how much NH3 is produced in grams, right? Now 3, how much excess reactant is left both in grams and moles? That's the question. And there's a few minor things in chapter 4. Let me cover that. It will take me about 10 minutes. Let me cover that if we have time today or next class. Okay, tomorrow. Okay. First thing. What was the first thing? Taeyong, what was the first thing?
You have to get the mole.
Moles. Mole is mass over molar mass, right? So this guy, molar mass is 28. 28, so that's 56 over 28. I get 2 moles. Here, that's 10 over molar mass is 2, 5 moles. Right? So we call this mole problem. Balance ratio, mole equation, right? Let me set it up, the fraction. So mole problem is N2 over H2, which is 2 over 5. I get 0.4, right? How about mole equation? That's a N2 over H2. That's 1/3 or 0.33. Who's bigger? That means 1 in denominator is your limiting reactant. Right? So in this case, the limiting reactant is H2. So I guess we'll have to calculate the amount of product based on the H2. So that's mass A. That's true A. Mass A to mass B, right? 그러면 10 over, that's going to be, molar mass is 2. The balance ratio is 3 to 2. What to start with goes to the bottom. And the molar mass of NH3 is 17. So how much is it? 170 over 3. How much is that? Yeah. 170 over 3.
56.7.
Right, so to answer these questions, limiting reactant is H2, and you said how much?
56.7.
56.7 grams, that's it. Then automatically we understand the limiting, the axis reactant is N2, right? Right. Okay, so in order to calculate the amount of leftovers, what do we do, Taegun? So this was limiting reactant. Step by step, think. What do we do? Cover.
Yeah,
Cover and calculate the mass again, right? So 없다고 생각하고 you calculate again. So that's going to be 10 over molar mass 2. That's 3, 2, 1. Molar mass of N2 is 28, right? Then 280 over 6. Please calculate someone. 280 over 6.
46.7.
Huh?
46.7.
46.7. So what does that mean? 46.7 required, right? Then how much is left? We do 56 minus 46.7. That's the amount left, right? How much is it, please? 9.3. Thank you.
56.7. So that's 10. Or 56 from N2.
Yeah.
And you subtract.
Yeah. That's amount required or needed. So that's amount left in grams, right? How about in moles? That's just mass over molar mass again. So 9.3 over molar mass is 28. That's left moles. How much is it, Pam? 0.3 moles left. Yes, simple as that. Okay. But there's one extra thing to consider. Okay. So based on our lesson, we concluded that the amount of NH3 that will be produced will be 56.7 grams, right? Right? But did we apply math or not? Math and calculator, right? We call it predicted yield or theoretical, I'll write down, predicted yield or theoretical yield. If we use math and calculate something, that's predicted yield or theoretical yield. However, again, will the lab always go accurately? You are likely to have less, okay? That's called actual yield. Because of human error, you will not have exactly 56.7, but little less, okay? So that we call actual yield, okay? So now, the problem. So, this is your predicted yield. The question says, oh, in reality, student retrieves 40 grams of NH3 during the lab. Then, this is your predicted yield. That's your actual yield, right? So now, last concept. There's something called percent yield. The formula is actual yield. Actual yield. That's percent error. That's slightly different. Now, over theoretical yield times 100. So in this case, that's going to be, using our example, 40 over 56.7 times 100. That's the percent yield. That's it. Okay?